So, this is going to be about reinventing some aspects or maybe even part of the ecosystem of Python packaging and testing. And, well, first of all, I'm very happy to be here. I enjoyed the last 2 days. I arrived on Friday morning, actually, and I had a very good time, actually, so far, especially yesterday evening. So thanks for having me here. My background, just very quickly, many of you might know that I'm in the PyPy project. I founded that almost exactly 10 years ago. I think it was something like on the 27th of February in 2003. But my other background is that I actually started programming, and now you're wondering how old I am, in 1986. For like a couple of years I worked for Electronic Arts and some other companies doing game programming. And I studied, after I did lots of programming, I studied computer science because I wanted to get to know a bit more about the background. I did lots of assembler, C, C++. And I came to Python around 2001 and founded PyPy in 2003. And I've also done a couple of other tools, PyTest, Tox, and so on. They're also going to briefly appear in this talk. But this is not a talk about PyPy, but about packaging. Let's first dive a bit back into history and go for something completely different. Now, you may remember that Perl has a mantra, a motto, which says there's more than one way to do it, right? Python has the contrasting mantra of there should be one and preferably only one way to do things. So let's keep this in mind for what comes next. Now, Python 3, there's lots of discussions about Python 3, but one thing it surely has done is it has beaten Perl 6 in terms of actually appearing, right? Perl 6 is an ongoing project, the second big version of Perl. It's going to be much better than Perl 5, and it's ongoing for 10 years. And at least we managed to get Python 3 out with shortcomings and criticism, but it's there for a couple of years and it's slowly gaining some kind of traction. So it's eating up on like Python 2, and we have beaten Perl there. But Perl is actually coming back to haunt us. Now, some of you actually may know, I'm not sure, how many of you know the comprehensive Perl archive network? Okay, that's a number of you. So I re-investigated a bit what they actually have to offer in terms of packaging and installation and so on. If you install any Perl interpreter, you get CPAN for free. It comes bundled with the interpreter. It can download and build, install, and test your packages before you actually put them into your environment. It has hundreds of public mirrors. It uses declarative metadata since about 2003, and it can verify the cryptographic signing of packages. So if somebody actually signs their packages on installation, you can verify if you are connected to some keyring that this is really coming from this author. The uploading part of CPAN is done by the PAWS server, also available for all companies and everybody to just use. It can enforce versioning semantics. It can you can have development releases that are mirrored across all the hundreds of mirrors, but they don't show up automatically. You have to actually point to the development version that you want to install. And they also have a policy for taking over the maintenance, for example, of abandoned packages. I mean, we have in the Python package index 29,000 packages, and a number of them are not really maintained anymore. If you do a bug fix, there's no easy way how you can actually do an improved release on that if the author is not reachable anymore. They have a process for actually handling that problem. They also provide for each user of the index a mirrored but unindexed place where you can put in some patches and special documentation and things like this and it's available to everyone, so if you have some special problem where you need a patch, you can just also get it from the mirror, it's just there. But it's all very organized. Let's look at the Python installer situation now, like today. We have no download and install tool coming with Python. We have two ways, or maybe even a bit more than two ways, to download and install packages, which is pip and easy install. And easy install actually comes in kind of like in variants. It comes from the original setup tools, which is, by the way, still which is getting active again. And we also have easy install distribute, which also supports easy install, and provides it in a slightly different way. And there are now packages, some packages, not too many, where you can only use the one version of easy install. So we have like two and maybe even a bit more of way of installing things. It's very slow. If you install a package, what actually happens with either pip or easy install, you look at the index and you see all ever mentioned homepages and download URLs. So for a project that is like 8 years old, it's a lot of URLs because the homepages and download stuff actually changes. When you install that package, the client, the pip or easy install, they need to look and crawl at all of these pages in the internet from your machine to see if there are packages. And that also means if for some reason the current download page is not available, you're going to install an older version. Right? Just silently, just happens. There's also no reliable way to test stuff before you actually install it, because there's so many ways on how you can run tests in Python. And even though you can, with your package, upload the cryptographic signature, no installer, neither easy install nor pip, actually do any kind of verification. So it's a bit useless. Let's look at the upload and Python package index interaction that we have today. Maybe some of you have looked at the PyConRu server code. It's a 10-year-old grown kind of a mess. It's working, but it's had security issues. Some of them very silent and very severe ones, which are not really standing much behind what we had in the Ruby world. Ask me over a beer if you want to have details there. We have no enforced versioning semantics. The versions can be all kind of wild stuff. We have no policy for this taking over of abandoned packages. And it's basically a brittle protocol. What I mentioned, this kind of crawling that each installer needs to go all over the internet and get stuff, also means that some of those pages are not reachable, you cannot install the package, and it's really not very nice. And most of the packages that we have are actually doing things through, and probably you are as well, setup.py, which is code. It's not a declaration of dependencies and metadata for your package. It's code, and you have to run that actually often to find out about the metadata, because some packages actually have different dependencies depending on the Python version and things like this, and people make this decision in the setup.py code. That also means that the server has no easy means to actually get at the metadata. Because on the server, you don't want to execute arbitrary setup.py code. Right? It can contain anything, because you can upload anything. And if you go out and install Django Unchained, for example, you can safely do it, trust me. Pip install Django minus Unchained, you're going to see what happens to your browser window and YouTube. And if you look at the mirror situation, let's first look at the CPAN mirror situation. They have 478 mirrored sites. Virtually all of them are okay. They are controlled all the time from several regions of the world. They are checked, everything is in sync, and you can use them. Let's look at the mirror status from PyP, I think 2 days ago. We have like 8 mirrors. 2 of them are unavailable. 1 has now been switched off. We have 1 which is 23 days old. We have 1 which is 4 days old. and we have like 2 or 3 which are kind of okay, right? Okay, I think we can stop the comparison already. It's not really a very favorable comparison. So let's look at what can we learn from that. I think there are 3 lessons to be learned. One is a very important lesson, which is if you start comparing what you're doing actually to others, you can very quickly get unhappy. I guess you know that feeling, right? You're doing something and you're seeing somebody else who's smarter and doing greater stuff or so. It's horrible. Perl and Python are both not living up to their mantras, to their mottos. I mean, Perl has like one way to do things. It's thought out. It works well. Everybody uses that. In Python, we have like multiple, all more or less flaky, broken ways, right? So, I mean, we're not really living up to what we consider the zen of our language. But it also means that's the 3rd lesson. It's not also bad because, I mean, we have a large community and I think we can actually improve on things. So, let's look at what happens currently. We have a number of projects and PEPs to actually improve the situation. Of course, we have the setup tools and distribute projects. They are maintained, both of them actually now, again. We have pip, which is very well maintained, and moving forward, we have a new thing called disklib, which tries to help with implementing the new PEPs. We have a different project, it's on GitHub currently, packagelib, which allows to use declarative metadata to actually install packages. So you can just define your stuff in a setup.cfg file, and that is actually the source of the information about the package. And we have a number of PEPs. 386 is like version comparison, so we get some sanity in the kinds of how we do versions, and we can eventually maybe even enforce that so you don't upload like unparsable versions. We have several iterations of new metadata, which tries to solve all the possible configurations you can do in setup.py and what people are doing to actually be able to express that in a declarative way. So tools can easily parse that and use this information. The current, most recent information PEP for that is PEP 426, and it's almost approved, and I think it's a pretty good thing. One thing that we have, I think that Perl doesn't easily have, is PEP 4.5, virtual environments. It's now part of Python 3.3, so you can easily create with Python 3.3 -m venv. You can just very quickly, it takes like 0.2 seconds or so, a virtual env directly from the Python interpreter without any kind of extra installation. But it still doesn't mean we have an installer. It just means you can create the virtual env. And there's recently, like last week, there was PEP 427, which is the real binary package format, which tries to avoid many of the problems that the setup tools ECK format had. And that is actually the one probably that is going into pip and going to be supported by installers, and it's kind of relatively easy to support the real format. So we have a number of things going on, but some of them actually require to kind of rewrite and do things differently compared to how we have done that before. And that is the problem I always see when like coming up with new approaches. If you have like so and so many ways to do things, and you say, oh, but it's all crap, you're going to, this is the right way to do it, you might just end up with yet another way to do it, and it doesn't actually substitute all of the existing approaches, right? And I think the lesson learned here when it comes to standardization is that if you do something and you have like a large existing situation, the way and methods how people are using things, then we shouldn't go there and say everybody has to change. You know, we have to do it all differently. Everybody should package everything in a different way, and then we are all fine. You know, that's something that's very hard to get through, and it's certain to actually lose thousands of packages which are actually in use. And I think it's a trap. Like also in many other situations, it's not really a good idea to just invent yet another way that is incompatible and where you have to like change the world in order to make it work nicely. So my approach has been, and my answer to this trap is a bit, write something like meta tools. Now what meta tools do is they invoke the existing good practices or what people are doing tools. And they may configure them in a certain way to run them in a certain way. Make sure that with that you can actually run and satisfy most, maybe not completely all, but most of the use cases that are already out there. So people can start using the tool, they don't have to change anything to their code, they just add a little bit of information, and then they can run this new unified approach. And then you can actually, when you have that, you have more ability to actually enable new facilities or new standards. And I'm going to show one example from the testing arena. That's a goat. And the goat has for some reason has been selected a couple of years ago as the mascot, the animal for things in Python testing. And so when I look at the situation, I'm the author of PyTest, and Nose was a clone, and there's lots of things going on. There's many, many good test runners that are used for good reasons. There's Nose, of course, very popular, PyTest, Unitest, Unitest 2, Zope testing, Twisted Trial. There's even other methods companies are using, which basically is make test, and they have shell scripts, whatnot. And also there is a method how you can, if you're using setup tools, you can actually define some actions that happen on setup tool, setup.py.test. But if you look at that, who would think that inventing yet a new way to run tests, like a new test runner, would help to standardize this situation? If you actually demand, okay, you should all use this new cool test runner, do you think you're going to get like most of the people actually using it? No, you're just going to end up with yet another method. Some people might like it, they may use it, but you just have added another way to do things. So it's not really going to happen to help unifying things. So what I did is I wrote a meta tool, because I'm kind of like constantly working in improving testing infrastructures, also for companies. And I wrote a meta tool called Tox. And its mission is basically to add on top of the existing stuff that we have and make it configurable in which kind of Python interpreters a certain project is supposed to run. It then goes there and installs a package into that virtual environment with that Python interpreter with the specific dependencies I have, so I can make sure that my package actually runs against Django 1.3 and Django 1.4. And then there's a command section where you can just specify what kind of test runner do you actually want to run. That means of all the, I don't know, I mean there's like 30,000 downloads currently of Tox. All the people actually who use this, they have a unique, uniform way to actually run their test. They just enter Tox and they say, run it on Python 3, run it on Python 7, and it goes and does all the stuff, performs the testing, gives you a report. It's a meta tool. It doesn't add yet another way, it's sitting on top. So that's testing. But what does this mean now for packaging? Well, I did a little prototyping in the last 2 months, basically. And it's going to be presented first here at PyCon Russia. And I'm very interested in your feedback, of course. So it's called DevPy. It's development supporting package index. And it's a meta tool for packaging activities and serving. So DevPy has 2 parts. The one part is a much more advanced index server implementation than what we have in Python.org. The second part is it also provides subcommands to help with the workflow of like uploading packages, also installing things and testing things, and some other bits I'm going to talk about in a second. And the way it does that is not that you have to change your projects or you change your installers. You can still use pip or easy install or whatever. You configure it in that tool actually how you want to do that. And you can also do this on a per project basis. But maybe you are asking yourself, why a new approach to index serving? Why are not just taking something that is there and improve that, right? There's many reasons for that. I have a number of use cases and one from an upcoming contract where people want to do something like in companies where they have development workflows, they want to have multiple indexes. So they want to have one maybe development index and one QA index where things are like ready for rolling into production, and then maybe a production index, and the system administrator is only ever going to install things from the production index, where packages have been like tested before and they are there and work. Also, one shortcoming I saw in the existing PyPy server implementations is that it's not so easy to have your private index, but still use all of the packages that are up there on PyPy-org, right? You basically have to manually put them there, and I wanted to make this more seamless. Also, I don't want this whole crawling business across the whole internet to happen from all kinds of servers, from all kinds of computers where I run the install command. I want to happen this at the server side. The server does the crawling, it knows then which packages are there, and it directly tells the client, these are the packages that are there, just go. I also want to have, in order to have more quality control for packages, which is also very important for companies, but I think also for the Python community, I want to have test results of people and even arbitrary users using a certain package to be able to upload their test and installation results to the index server, so that when I want to install a certain package, I can see, okay, it actually runs on Windows, it actually runs on Linux 64-bit and things like this, right? So I can directly see that. And I definitely want to allow seamlessly working offline. So if I'm working with an index, like I'm going on a plane with my laptop, I want to be able to continue working with the index with the packages that are there. I mean, if I'm requesting something that is not there, okay, bad luck. But most of the time, my index just populates all the stuff that I usually need and the versions. And I just want to be able to continue using it while I'm offline. There's a few more things, but I think these are the main points. Now, this is all very nice and all the criticism and all this, but show something that actually works. So what I'm going to show is, like the current command is called devp, and the subcommand is called server. What it does, it exposes multiple indexes that you can use on the fly currently, and they are organized as a per user thing currently. So you have the user part, and then the index name that you have. And that can be, you can have arbitrary many indexes per user. Each index defines an upstream index. And that means when I use that index and the package is not locally in that index, it's going to grab it from another upstream index and basically cache it at that index location. Right? Also, each of the indexes that I have is completely crawl clean. So the server does the crawling, the client side never ever needs to go back to the internet. Uploading a package to my specific user-specific index does not automatically push it upstream. It's just in my local thing. So if I have this as a company and I push a certain private thing that's not open source licensed to this index, it's going to sit there, and unless somebody actually pushes it explicitly to PyPy-org, it's not going to be available somewhere else. You have to actually say, okay, really want this released to PyPy-org. And of course, and that's the whole point of this thing what I said before, it's compatible to the existing tools. So it works with pip, easy install, and setup PyUpload, and all the existing workflows that we have. Okay, so that's the theory of that command. And now let's see if I can show you some nice live things happening. I hope I have somewhat of a network. I can also work offline, of course, but I'd like to show you some things there. So let's start by creating a fresh, you can see that? Yeah. Okay. Let's start by creating a fresh virtual env. Sorry. I create a fresh virtual env. And now let's maybe just take a look at an arbitrary index that we're going to use. So here we have in this index, I mean the web interface is very simple currently, it's just functional, right? It's not fancy, no Twitter bootstrap, whatever. So there's nothing currently. Now I just go and say, and let's do this with a time command, and now I hope I have enough connectivity to actually do that. So I go to this localhost server, and of course it's using the number P as a port number. Sorry. So what did I say? I'm going to use HTTP 42 def1, and that's the simple index that you also find on python.org. You have to specify that, and I'm going to install the distributed version of PyTest where you can run things in parallel. And of course, I've already done that some time before. I'm going to uninstall all the crap. Okay, so I'm installing that, and you see that it's very fast because, wait a second, what was it using? It's of course always let's see. There. Okay. So if I look at the packages that are currently in here, there's the PyTest package, and I just need to see, I'm sorry, I'm a bit slightly confused. Why this is happening so fast currently. Let me just take second index. It's much too fast. Okay, let's, I have an idea. I didn't actually show you, the, where's my dev.py server currently? Right, it's there. Let's just kill it. Let's remove all of the state of the server, which is currently here, and let's start fresh. So, it's really a bit, things are always, so can I now actually start? Yes, okay. Now it should be fresh, and there should be nothing on that index. Okay. Now I'm going to this one, and I'm going to source the environment. I think that's the thing that I missed actually. I'm going to source the environment that I just created. That's why. I was actually installing something that was already there, so nothing much happened. So now, if I look, there's nothing installed. And now I'm going to do the install command again. It's a lot of typing, and I'm going to time that. So let's see. That's what I wanted to see. That's the normal way how things happen. Because it's like crawling all of these pages, the client, right? It's getting the index information, it's crawling pages, it's downloading things, and so on. And you end up with like 16 seconds for installing these 4 packages, and if any of the sites were not reachable, which were required, then you have a broken installation. If you now look at the index, these 4 packages are actually here. And I can check what is on that index. And you see that there's all of the package releases are there. And they're all coming from upstream. The upstream here is https python.org, right? And they're all cached at my local index when I access them the first time. They're not automatically like put there. It's a policy question. If you want to do that, you can of course also do that. But usually the like quick usage is to just say when you access them, they're going to be downloaded once, and then you install it from there. So if we do this a second time, we uninstall the stuff again. We do this a second time. The first time was like 16 seconds, and this one is like 1 second, right? Because it's just going there, things are cached, everything is there already, no problem. Now let's actually upload something. For uploading, I'm using the, what was it, the dev1 index. For uploading, I need to actually not specify a URL, because that's the way how distutils work. You actually have to have a section in your PyPRC, and then put the repository URL there, and then you use this name. So I'm using, you see here, dev2. We have to use dev1, because that's the one we are currently using. And okay, I have to list it here, so I have to modify this file. Don't look at my password. It's anyway wrong. And then I can actually use that to do the sdist upload using that dev1 server. It has a bad gateway because I just lost wireless connectivity, and so it comes back. No, now I have disconnected. We just check if we have a chance to actually get it back. Uploading, but it's an interesting point. You get a bad gateway. Actually, the index server, of course, always gives you very good HTTP return codes, right? And so, in this case, because the upstream was not reachable, your setup uploading things actually got a bad gateway because it couldn't actually get to the different thing, and it needs to go upstream because I'm trying to upload a package that has versions on upstream, right? And the index makes sure that you don't upload something that already exists in upstream at the time. So it synchronizes at that point when you're uploading. And maybe we have a chance to actually run this when enough people have switched off their wireless, so my wireless works. Okay, let's just see if that works at some point. But you get the idea. I mean, this, if you upload this, then it's going to be in the index. Maybe somebody can tell me if the wireless is there, then we can repeat this step. Okay. So, oh, and one more thing. The way how this is organized is such, I mean, I have the server running here, right? And if I actually interrupt the server and there's no server running anymore, then of course when it's there, of course now, quick, let's be quick. Yeah, that's the problem if you work with PyConRu. Yay! So if you now look at let's look at what we have in the index here. You're going to see that this is going to be the next release of this Py library, which is a dependency, and it's 1.4.13, and it's not only in my local index currently. It's not at py.py.org. So of course, when I now uninstall things, and I now install things again, and I look at what is installed, of course I get 1.4.13 now. Because it's my local index, it overlays what is coming from py.py.org. And another nice feature here is that if I now turn off the server, the Python devp server, I can actually go and look at my Nginx configuration. And it's this, very simple. It's actually serving a specific directory in that is actually populated from my devp server. Because the devp server works like this. It actually maintains a set of static files that you can async around to like many mirrors, if you like. If you upload something, then this static structure is modified. But that means you can just forget about the DevP serving, put in Nginx, and use that. And if I now install, I can use localhost, which is Nginx, and just install from there, right? So it's you don't depend on the stability of the server that much. You just have an Nginx front end. Whenever there's something missing, then the Python version needs to get going. But there's only one situation where the Python code actually needs to do something, or two situations. One is when you're uploading something, which happens relatively rarely, and when you are accessing something which is not yet cached. Right? In that case, it needs to actually do some work that Nginx cannot do. But once it's cached, it's just there, and you can use a static web serving for this kind of stuff. Okay, so that's one of the several of the ideas that are implemented in this server already. Let's look at what we have. This upstream merging makes making a private overlay in your company or for your laptop very easy. Makes it also very easy to have a testing release to see if things work. Crawling at server side makes it very fast and very reliable to actually do your installation. And it maintains this Nginx compatible view, which makes it very easy to mirror out to many sites. But you also noticed me struggling to type all of this, like modifying PyPRC with clear text passwords and going to pip and doing this installs. And I can set an environment variable, but if I'm changing the index, I need to change that as well. So I need to juggle these kind of multiple index URLs. It's not really fun. And that's why DevP has a second part, which I call the workflow part. It has a few workflow subcommands that allow you to set the current index that you're working with. So it's my development index or my production index or things like this. It has an install command, which just invokes pip or easy install to actually install stuff, but it configures the command. It actually uses the right index that I'm actually currently using without me having to type all the stuff. Uploading also makes sure that I actually upload to my server, test, gets a package from the index, and runs. And for that, you actually need to have a tox.ini file, tox.ini file defined, and then it actually goes and runs the tests and reports back the results to the index server, so that you can then actually browse at the index server level what is there. And push is the interesting command to actually shift a package from one index to another, for example, to python.org. So I think we have enough time to do this. Let's see. Why is this? Okay. So, DevPy use. I'm going to do it here. So again, I'm setting this once now. Right? This is the DevPy. Okay, the server is not running currently. We need to start it again. So, it's a REST API. So when the DevPy, the command line actually goes to the server and asks, okay, what are my endpoints for the simple index? What is my endpoint for submitting a package? What's the endpoint for pushing a release somewhere? What's the endpoint for pushing test results to the server? And what's my upstream URL for this index? So, and it's stored in this as JSON here in this file. So when I'm anywhere below that, like in my project directory, I can just check, okay, where am I working on? Oh, I'm on this index. Then let me do something. And I can actually do things like install. Of course, I need to uninstall it again. And then I hope that I haven't tested that actually, but let's see. Yes. So it just uses, and if you look at what it is invoking, it's invoking more or less the same install I did before. You know, just configuring pip to actually use this. So I don't have to remember all of these options and mistype, and just all dependent on what the server tells me are the endpoints for doing things, right? So the server can actually change its layout, and I just do a refresh on the using part, and I have the new endpoints. The other interesting command is the test command. I mean, I'm a testing guy, so what does def by test do actually? It takes the same arguments than tops, the meta test command I talked about. So you can say, okay, get me this package, run it on Python 2.5, run it on Python 3.3, and do that for me. So let's do that. And let me just test. The index is not important, the virtual environment I'm in here is not important because the test command actually creates new virtual env environments, because it's anyway very fast to do that now, that you can install things very quickly. So let's just maybe use one interpreter here. Oh no, let's just go for two. So that's the release I want to put up. Installation creation goes very fast and runs the tests. And then it uses the result log endpoint of the index server at the end and pushes the test there. So if I look again at this index and go to my wonderful HTML interface, then I see this package actually is only in stage. It's only in my index currently, and it has run already 819 tests on Python 2.5, and it should be finished with Python 3.3. And now you can go to basically, if that index is somewhat available to your company colleagues or to other people in the internet who want to test out if this works, they can just go there and say def by test on my machine, and they're going to download stuff, run it there, post back the test results, and I as a developer see, okay, it's running for a number of people actually. The tests are running fine in different environments. I'm going to release. So it's a completely managed process where people don't need to have hairy things to have this defp command to have installed, and then they need to know the index to use, but then they're good to go. So we should have Python 3 now here, and if you have Windows, then it's going to add up and collect all of these stuff. If you want to see my wonderful test representation, how it works, so each of the tests has platform information and MD5 information, and I hope also in the future signing information. And then you have like a super modern view of the test results. Okay, so that's that. And let me just go to the next command, which is push. Push means I'm pushing a certain package, or I need to actually specify the release as well. And I'm going to say I want to push this to a different index. I'm not going to push it to PyConRu at this point because I want to run the Windows test actually first. But I can push this version to another index I have on the internet, which is at pyptestrun.org. I can just use that. And if I have internet, I'm actually going to see if I can do that now. Depends on the internet, because now I'm really reaching out. So let's see if that finishes at some point, but you get the idea. You just push out this package to another index, which might even be in your same company on the production server or whatever. It's kind of like how you organize this workflow of putting things around or publishing on PyConRu is your thing. Okay, so a typical open source workflow is starting the server on my laptop, using a certain index, uploading, then testing for multiple machines, and then looking at the test results. I'm happy, and then I'm good to go and push the stuff out to PyConRu. And you are completely sure that the exact binary package, I mean bit for bit, that stuff has been tested on multiple platforms, and exactly that file is going to be put out, right? It's different from if you just do setup py and you run some tests in your checkout, And then you upload something, oh, I forgot a file. Or, oh, this actually was running my upload on the wrong Python version. Ah, damn, I lost something, you know? And your release is going to be balked. You're really sure that this particular package actually passes the tests on the different platform, and exactly that is going to be, by the server, pushed to a different index. So what's the plan here? The plan is I want to, of course, open source that and to make it available sometime soon. It's still kind of a prototype level on some issues. I'm doing lots of test-driven development, and of course this whole thing contrasted to PyConRu has lots of tests, functional tests, also some unit tests, and so on. What I want to do actually is I want to get relatively soon early adopters who actually use this for their release process, and we actually together refine the options, the way how things work. I don't want to go massive immediately with this. I really want to sort some things out and adapt to how things are doing and streamline some things. And I also don't want currently to aim for publishing a new standard or something like this, because this is not really requiring anything much to change. Just a new workflow tool, a new index server, and it interoperates with all of the existing tools and other services. My priorities personally are I'm going to support especially use cases from contracting companies. I hope to close a contract tomorrow, or Tuesday actually, with a big company who has a need actually to have their whole 600 people workflow sorted in a better way and have a better package index server in their facilities. And of course the use cases from my own and from fellow people open source work, that it works for them nicely. Okay, open areas, just in case you're interested. I'm thinking about, currently I'm using SQL for index serving, but there is, I'm actually investigating, because I did this in a different project, the possibility to store the persistent information of the index in something like Git or Mercurial, because I want to actually track any change that has ever been made to a package, to a certain package. So if somebody actually does a new release or deletes a release or updates the metadata or modifies the digital signature of that file, I want to have that committed. And I want to have a log of all changes that ever happened to this project. And I want to be able to actually clone this to different hosts. So if somebody goes on my server and tampers stuff, I have an easy way to actually detect what happened. Or if somebody manages to steal credentials, modify stuff, I at least have a very clear revision history. You see the journal on PyConRu, it's doing that actually. It's actually showing you per package what has happened to this package, but it's in the SQL database. So if somebody hacks the PyConRu server, he can just modify these things and make his modification invisible. And it's not so easy to compare things like two SQL databases that are live in production, right? So with the VCS, this is kind of simple. I mean, if I have a clone somewhere, I can easily detect if something has been changed in history, right? So maybe it makes sense to actually use VCS for that. Flooding systems so that people can adopt the various subcommands, workflow commands to their needs. Mirroring is already there basically, because you have the static files and you can just copy them around just with a CP command or async. And then also to support new things like the new PEPs, declarative metadata, the wheel format, and see how to best fit that in. But if a package, for example, says, oh, I have a wheel format here, then the devp meta command can actually detect, oh, I can use the wheel installer for that. So I don't even need to wait until setup tools has support for the wheel format. I could actually do something here at the devp level already. And that's what I mean, like this meta tool approach means you can use it and then add some things on top without requiring the world to change first. Also, I have been thinking 2 hours on Friday. That's also a very good outcome of PyCon Russia with Armin Ronapa about the issue of code signing and verification with Python packages. And we've written up a little document that we believe actually makes sense to and is practical to implement, because there's all kinds of systems, but the problem is always with public key infrastructures to make it practical. And maybe we can do something there. I also am thinking about not only making it possible to run this on a laptop or a company machine, but to put out a global service, which of course means that it needs like GitHub login and stuff like this, OAuth and whatnot. And I'm not very good at that. You don't want me to do that. So I need actually other people who want to help building like a public-facing index server for that. And I also am thinking about how to use this, okay, I'm almost done, how to use this for a continuous integration service. And that means that things like what Travis is doing, Travis CI, or what Jenkins is doing, all this stuff is already here, and the idea is to make it possible to arrange this kind of staging thing so that per commit things are run automatically on a server like this, and you have basically per commit a certain index, and can just use that and can store test results there, and it's directly usable. So you don't need to refer to Tabors, you can just use your normal installation tools, and that's also a possible idea. Okay, that's basically it. I'm here until Wednesday morning. I'm also happy to have a little party again this evening, and thank you very much for listening.
Ваши вопросы?
Yes.
I think this is a great project. I have one question. Say we have two unreleased packages, and one unreleased package depends on the other. So with this, with DevPy, we can upload the unreleased package locally. We can upload both unreleased packages locally, and then just run the DevPy test. But what should do contributors to this package? So they should download both packages, they should start DevPy, they should upload these packages from checkouts to DevPy, and then run tests. Can this workflow be simplified? So they can just, for example, download the package and run talks against the unreleased version.
I mean, basically it's a URL that you are giving to people and say, okay, if you have DevPy installed, then you can just use this URL, and if you want to have other people be able to, for example, upload branches or like modifications of that package, then I would say they could either do that in a different index, right? In their own index, or own user-specific index, a bit like how Bitbucket and GitHub works.
Yeah,
right?
but with the talks we don't need for URLs. We can run tests against the local checkout.
Okay, yeah, but that's what's happening. I mean, the DevPy test is just a shortcut for downloading and running talks. You know, so you can do that. You can just download that package, exactly that package, unpack it, and run talks in there. The only thing that's
this done by each contributor. Each contributor have to set up the DevPy. He can just download and run tests to check if.
you mean, okay, it's not contained in the package itself, right? That's what you mean. Yeah, that's true. I mean, that's true, but people need to have setup tools or pip or something like virtualenv also installed. And this just is another thing that I mean, if you have a project and people are, you know, working together, they anyway have their ways of doing things. Like you need certain tools, have certain dependencies to work on this project. And that actually adds a dependency. You need to have DevPy installed to easily integrate with that workflow. Now, putting all of that inline into a package, you could do that. I mean, there's a Tox Bootstrap, for example, that does that for Tox. You don't need to, you can just put the Tox Bootstrap in there and do that. And we could do this with DevPy as well. So you just need the package and then can run it. But that's exactly the kind of thing I mentioned about That's what I want to discuss with the early adopters, to see like what concrete use cases actually are there where we want to modify the behavior of what is currently there, right? Because I cannot foresee all the possible different combinations of what people are doing. I mean, I have some insight, but don't know all of it.
Еще вопросы?
Thank you for your hard work and outstanding presentation. I have a question about binary distribution, but not the X binary, but native code binary, like NumPy, PyOpenSSL, Wix, Python, and so on. How your system will handle Python native code extensions?
Currently it doesn't, and I think it's an interesting question because the index actually is, I mean, it manages this kind of metadata keeping and discovery for pip and easy install, but it should be easy actually to add something that you can also upload different things that NetPy is able to discover and actually install, for example, in a Ubuntu 12.04 specific manner or something like this, right? But that's also something that can be added on top. I haven't thought this through yet. I mean, I think it's a very provisioning in certain operating systems for your production servers is a very important task. And I think this can be used actually eventually to organize this as well, but it's not currently done.
Thank you.
Holger, I recently in our company deploys a local PyPI server based on local shop implementation. Maybe you
Local shop.
local shop.
That's actually one I don't know. I know I have looked at several.
It's cheese shop and local shop.
Okay, I know cheese shop, but not local shop.
There are many PyPI server implementations,
Yes.
and I have chosen this one. It also supports package mirroring from the upstream. It allows to upload local packages and so on.
Yes.
Why you don't use any existing implementations, maybe for faster bootstrap of your development? As I understand, you develop your implementation from scratch. Yeah.
Not really from scratch.
And main feature of this implementation that it already uses Twitter Bootstrap for UI.
That's UI. Well, the thing is, I looked into, I think, 6 different implementations. I contacted 3 authors that I actually wanted to ask about their maintaining status and so on, and I asked them again, and I asked them again. I got no answers. So there's many PyPI servers on the PyPI package index that are kind of unmaintained, right? So that's one of the problems. The other problem is that most of these, no, all of these index servers, they didn't come with tests, you know. And when I'm actually doing a new project and I want to do a lot more functionality, I'm not going to base this on something that doesn't come with like tests, right? It's not my thing. I mean, PyPy has like 17,000 tests, and it's part of the reason why it's kind of like very stable in terms of supporting compatibility. And this project is a prototype and has already 120 tests to actually run. Now, some people find this crazy, but I'm not going to do a project like this that needs to work very reliably in many situations and base this off an implementation that doesn't have tests. Because usually if you have a project that doesn't have tests, it means it's also not very easy to add tests, right? And I didn't want to spend my time this way. There's one exception, which is a PyPI server from Ralf Schmidt, which is called PyPI server. And it's actually quite simple and small, and has many tests. And actually, I used this as a blueprint kind of thing. But it was a very simplified version. It didn't do anything of the things I wanted to do, just the very basic stuff. So I just used this, and then I used PyPy-org, the horrible implementation, as a reference to know what it is actually doing. You know? So it's, I mean, we have to discuss this over a beer. I mean, maybe there's something I missed that would have been the great base to do this. But from the 6 projects I investigated, it didn't feel like this. I need to stop,
Yeah.
right? I'm sorry.
Maybe you have
So I'm here. Yes. Thank you.